For this assessment, I've set up a problem that requires you to write a function. As you can tell, these are becoming a little more complicated. But let's break this down into its parts and solve it one step at a time. You're asked to write a program that reads the list of values from the user and determines whether it is friendly or not. And the concept of a friendly list is one where two neighboring values are the same. 5 and 5 here, for example, are the same in the list 4, 5, 5, 6. And that's a friendly list. However, 1, 2, 1, 4 as a list is unfriendly because there are no neighboring values. To solve this problem, really make sure you look at the lecture notes for day 7 because it sets up the framework that I'm going to use. Let's start. And when you're trying to solve these questions, the first thing to do is put aside the fact that you don't know what's going on and instead just get started on the structure. To write a program that reads the list of values, this is simple. This will be my quick program. Because it's reading a list of values from the user, I have a function that doesn't take any parameters. Instead, the user will give me the information. So I have to prompt the user for that. So I'm going to say vals is equal to input, please enter list. And I've used this notation before when asking the user to enter in a list. I can use input that Python gives us as a capability, and it will indeed allow the user to enter in a list with brackets separating numbers with commas. Let's just make sure that this works before we go on any further. And this is another thing that I would recommend that you do. Run your program frequently. As you make a small change, run it and see if it does what you expect that it does. So here in my program, when I run it, enter in the list of numbers 2, 5, 7, and it prints it back, so I know I have step 1 complete. Now that I've read the list of values from the user, how do I know whether that list is friendly? Well, you know you have to do something for every element in the list. That makes sense. Because the only way to find out if it's friendly is to find two neighboring values that are the same. And if I actually had a list, call it x, I know that this list is friendly because x of 1 is that middle 5, and x of 2 is the rightmost 5, so they are neighboring each other because these index positions are 1 apart. Oh, how am I going to do this? Well, if you were going to do it just using your eyes, you would say, is 1 the same as 2? No. Move on. Is 2 the same as 1? No. Move on. Is 1 the same as 4? No. Move on. And then you run out. And so you'd say that's not friendly. If you reflect on that for a moment, recognize that you had 4 elements in the list, but you only did 3 checks. Is 1 the same as 2? 2 the same as 1? 1 the same as 4? So I want to do something for not every element in the list, but every element in the list but 1. Now you've seen in the lecture notes this command called len. And I'll just make a note here that list has len elements. So if I wanted to find out how many elements are in a list, my len function tells me that. It will, given a list, it will count how many elements are in there. So now I type my program. It tells me that it has 3 elements. So if I wanted to check if 1, 2, 1, 4 was friendly or not, I've got to do 3 checks. Well, now that I know I need length minus 1, let's put that conveniently into a for loop where I want to check, is the 0th element the same as the first element? And then is the first element the same as the second element? And the second element the same as the third? Once you have that, you can recognize this is going to be a for loop, a definite for loop. And you're going to say, well, for I in range of, and now comes a question, do I use length or length minus 1? Let's do length minus 1 and see what we get when we print out each of those values one at a time. So if you did type my program 1, 2, 1, 4, I want to do something 3 times. First for the 0th one, then the first one, then the second one. Excellent. We're almost there. What is it that I want to do for every one of these index positions, 0, 1, and 2? I want to check, well, first let me show what happens when you print out that element. Again, a small little change here will show you that when I have my values, I can now print out 1, then 2, then 1. Getting closer. I want to be able to check whether an element is the same as the element to the right. If you think about using index positional into a list, vals of I is a particular element. What is the element to its right? It's nothing more than vals of I plus 1. So if I did it like this, let me put this into a string. And now what I've done is put together a nice little program that asks a very simple question. Is 1 the same as 2? Is 2 the same as 1? Is 1 the same as 4? Well, if you ever find that they are the same, you know that you're friendly. If you find that you're not the same, you're not friendly. So let's make another final step here. We know when this is done, I want this one to determine whether it is friendly or not. Determining is a very vague word. It could mean that it prints it out. It could mean that it has to return a value. In my case, I'm just going to take the simpler route and just assume it means I want to print out that the list is friendly. Let me assume that my list is not friendly. Boo, it's not a friendly list. But if I get to the very end of this for loop, and if it turns out that I'm friendly, then I want to say, yep, this, or to be more precise, vals is a friendly list. Just leave it at that. Now I only have one more thing to do. This is not going to print anything out other than the intermediate values I had before. It doesn't yet tell me whether this is friendly or not friendly. So instead of having an if statement where I say it's a friendly list, else it's not a friendly list, I'm just going to put in a final statement that says one quick check, and it'll say the following: print string variable is a friendly list, and then I will answer that by putting in here friendly. So you should be able to see, I hope, that we're just composing together all the different things that you've learned about in this course so far, putting them in interesting combinations. This final step here now, as I run it, 1, 2, 1, 4. Is it a friendly list? It says false. So it looks like I'm done, but of course, hold on a second. I didn't actually try it out with a friendly list like 4, 5, 5, 6. So clearly I'm not done. I have to do my final check. And here's the check. If I ever find out that vals of I is the same as vals of I plus 1, I know that I'm a friendly list. But printing is not going to help me with that. Instead, what I need to do is something that checks. Is vals of I equals to vals of I plus 1? And if it ever is, I know that I am a friendly list. So friendly can now be set to true. And with that, I've completed the assessment. Let's run. When I run my program on an unfriendly list, it will say, is it a friendly list? False. When I run it on a friendly list, it will find that it's true. And the trick is to recognize that I need to do a for loop for every element in the list but 1, because I'm going to check that element against the one to its right. That is done by this if statement. If vals of I is equal to vals of I plus 1, the next one in the list, I set friendly to be true. So this is a standard template that I write all the time. I assume some hypothesis that it's not a friendly list. If I find that it is friendly, I'll change my mind and set friendly to be true. And then when I'm done, I have the determination whether it's a friendly list or not.